Welcome to lesson 1 of 2 in this tutorial, covering static charge. This is our first video in our series of 2 lessons on the topic of static electricity. Here are the key learning objectives for this lesson. We'll start off by looking at charging materials and then at static electricity. Here are the AQA specification points for this tutorial. Feel free to pause the video now and have a read through them before we begin. We'll cover the charging of insulating materials first. You can charge certain insulating materials by rubbing them together. For example, if you rub together an uncharged plastic rod with an uncharged cloth, both of these items will get charged. As we rub the rod with the cloth, the electrons will move from the rod to the cloth. This makes the cloth negatively charged, whilst the rod becomes positively charged. Remember, only negative charges can move. Positive charges cannot move. The positive charge of the rod should be equal to the negative charge of the cloth. The number of electrons gained by the cloth will therefore equal the number of electrons lost from the rod. Remember, the positive and negative charges will always be equal to each other, since the electrons are simply moving from one object to another. As one object gets more positively charged, the other object gets more negatively charged. Next, we will look at when electrical charged objects exert forces on each other. Two electrically charged objects can exert a force on each other without directly touching. This force is an example of a non-contact force. Two objects with the same type of charge will repel, and two oppositely charged objects will attract. The force between unlike charges is called electrostatic attraction, whereas the force between two like charges is known as electrostatic repulsion. Our next specification point will look at objects exerting forces of attraction and repulsion. Similar to other forces, electrostatic forces can cause movement. Electrostatic attraction will cause objects to move closer together. If we think back to our example with the rod and the cloth, the positive rod will attract the negative cloth, meaning that they move closer together. Electrostatic repulsion will cause objects to move further away from each other. Let's look at our next specification point, covering the transfer of electrons. When we rub two surfaces together, we are producing static electricity. This occurs when electrons move from one surface to the other. We get a build-up of static positive charge on one surface and an equal static negative charge on the other. As charge builds up on the surface, we start to create a difference in charge between the charged surface and Earth. Usually, the Earth is at 0 volts. As we charge the surface, the difference in charge between the surface and the Earth will get bigger and bigger. Static electricity can lead to sparking. Eventually, the charge difference between the Earth and charged surface gets so big that electrons will jump from the charged surface to the Earth. As electrons jump, we will be able to see a spark. AQA exam questions on static electricity tend to focus on real-life scenarios, allowing you to apply the principle of electron movement and charge difference to them. Now, we will look at the production of static electricity. Let's have a look at this exam practice question. Feel free to pause the video now to attempt the question by yourself. Let's work through it together step by step. When the balloon is rubbed against the jumper, we're going to get an electron transfer. The electrons will be transferred from the balloon to the jumper, resulting in a negatively charged jumper and a positively charged balloon. When Laura touches the jumper, the electrons will be transferred to her. Compared to the jumper, Laura will be positively charged, so electrons jump across the gap between the jumper and Laura's hand, creating a spark and therefore an electrical shock. The electrons are trying to get to the Earth, so they will travel through Laura's body straight down into the Earth. In this situation, we refer to Laura as the earthed object. She is in contact with the Earth, and therefore she's providing a pathway for the electrons. When approaching 6-mark exam questions like this, it's always a good idea to have a step-by-step approach. In the last question, we had 3 steps. This will allow you to give your answer some structure, whilst exploring all the points in detail. The AQA specification does not ask you to memorise the uses of static electricity, but often, exam questions are based on real-life scenarios. If you've read about the scenario before, it can help you answer the question more easily. Pause the video here to take a look at 3 uses and 3 dangers of static electricity, but there's no need to memorise this. Now let's try a practice question. Which of the statements below are true? All of them except B are true. B is not true because the hair strands will all have the same charge and therefore repel each other to stand on end. A is true since electrons can move but protons cannot. C is true since the electrons will move from the rod to the cloth. The protons will never move. D is also true since friction can cause the movement of electrons. We've now covered all the learning objectives for this lesson. Feel free to skip back through the video and re-watch anything you are unsure about. We've now completed Lesson 1.